All right, so in this case, we've already talked about something like this, where, like in the hydrogen, where these electrons here, these are equally spaced between those two oxygen molecules. Neither oxygen is pulling at all on it. So the bonds are not polar. And if you have all not polar bonds and no lone pairs, then what you basically have is a molecule that is nonpolar. So in this case, it's tempting to say that this electron density in the double bond is going to override the other electron densities because you're like, there's twice as many electrons in there. But the molecule doesn't see it that way. And so we're just kind of imagining that's a blur of density, and we are not worrying too much about the fact that there's 4 electrons instead of 2. It's very odd, but it doesn't count it that way. So, and the other reason about this is, remember, this is actually in resonance. So the resonance, if it did matter, the resonance would cancel it out. So all of these are all going out, and notice that there is no lone pair on it. And so the bonds are, yes, they are polar, but the molecule is not polar. If we want to use a little chart here, are all the outer atoms the same? Yes. Are there lone pairs? No, it's nonpolar. All right, here's another one. This density you might be more comfortable with because the double bonds there. So are the bonds polar? Yes. Is the molecule polar? No, because it doesn't matter if the electrons are here or if they're sitting right there on the oxygen. They are like equally spread apart and in the equal direction by the equally same amount. Then the electron density isn't heavy on any part of the molecule. All right, so y'all can see right away we've got that dipole. Now, interestingly enough, these are oxygen, so those electrons should all be sitting right there in the center, and those should be sitting in the center. So these bonds are actually not polar, but the molecule is polar because of that lone pair on there. So that's kind of interesting. So in this one, are the bonds polar? Yep, they're going like that, and they're going like that. My arrows are always pointing to the most electronegative atom. And overall, yeah, I've got a great big dipole on that one. So the bonds, yes, are polar, and yes, the molecule's polar. And if we look, are the outer atoms the same? Yes. Are there lone pairs? I'm sorry, are the outer atoms the same? No. So that one automatically gets a straight up polar. All right, so over here, now you can see these are kind of equally spaced. They're actually all going out. So yeah, the bonds are polar, but is the molecule polar? No. You can look over here. Yeah, they're the same. Other lone pairs? No. It puts us at being nonpolar. Now let's check this one out. We've got a lone pair right here that's going to be overriding a whole lot of the effects of any of the bonds. And then this is going like that. So the bonds are polar, yes. Is the molecule polar? Yes. So if we follow this again, are the outer atoms the same? Yes. Are there lone pairs? Yes. Is the shape either of those? No, it's polar.